The Evinrude 300XP is a legendary high-performance two-stroke outboard motor introduced in the late 1980s and early 1990s. Designed for speed and power, it was one of the most powerful outboards of its time, producing 300 horsepower from a V8 configuration. Built with Evinrude's racing heritage in mind, the 300XP quickly became popular among offshore racers, performance boaters, and enthusiasts seeking unmatched acceleration. Its distinctive exhaust note and raw two-stroke power delivery set it apart from competitors. Though discontinued, the Evinrude 300XP remains a sought-after classic, remembered as an icon of outboard engineering and high-performance boating. The Perkins P6 engine was a six-cylinder diesel engine widely recognized for its durability and reliability in agricultural machinery. Originally produced by Perkins engines in the mid-20th century, it became a popular choice for Massey Ferguson combine harvesters, where dependable power was essential for long harvesting days. With a displacement of 4.7 liters, the P6 delivered steady torque at low RPM, making it well suited for heavy field work. Known for its straightforward design and ease of maintenance, the Perkins P6 earned a reputation as a workhorse engine. Many vintage Massey Ferguson combines still operate with P6 engines, reflecting its lasting legacy. The Atlas Copco compressor, powered by a two-cylinder Deutz motor, delivers reliable, efficient performance for demanding industrial and construction applications. Built with durable components, it ensures consistent air output, easy maintenance, and fuel efficiency. Its compact design makes it portable and versatile, ideal for powering pneumatic tools in tough working environments. The Connecticut Antique Machinery Association, CMA, in Kent, Connecticut, preserves and showcases the rich history of early industrial technology, including an impressive collection of steam engines. These steam engines, once the backbone of factories, farms, and transportation, demonstrate the innovation that powered America's growth during the 19th and early 20th centuries. At CAMA, visitors can see both stationary and portable steam engines, carefully restored to working condition by dedicated volunteers. The museum highlights how steam transformed industries such as lumber, mining, and textiles, offering live demonstrations during special events. By preserving these machines, CAMA not only honors past engineering achievements, but also provides hands-on learning experiences, making history come alive for new generations. The Deutz MAH 914 is a single-cylinder, four-stroke diesel engine produced by Klockner Humboldt Deutz AG KHD in Germany during the mid-20th century. Known for its robust design and longevity, it was widely used in stationary applications such as pumps, generators, and agricultural machinery. With a displacement of around 10 liters and power output in the 40 to 60 horsepower range, depending on configuration, the MAH 914 stood out for its simple air-cooled system and direct fuel injection, which made it reliable under heavy workloads and in remote locations where water cooling was impractical. Its slow revving operation and characteristic diesel knock became a familiar sound on farms and work sites across Europe. Paired with a Kramer grist mill, the Deutz MAH 914 found a particularly valuable role in rural food production. The engine provided steady, torque-rich power to drive the millstones, or rollers that ground grain into flour and animal feed. This combination mechanized a task that had previously required far more labor or water-powered installations. Together, the MAH 914 and Kramer mill symbolized a transitional phase in agriculture where dependable diesel power replaced traditional methods, boosting efficiency and enabling farmers to process grain on-site with remarkable consistency. The Hundusted Type EL hot bulb engine is a classic example of the semi-diesel or hot bulb engine design that was widely used in the early to mid-20th century, particularly for marine and stationary applications. Built in Denmark by Hundusted Motor Fabric, these engines were renowned for their robustness, reliability, and ability to operate under harsh conditions with relatively low maintenance requirements. The hot bulb engine operates on a principle between the true diesel and early crude oil engines. Instead of compressing air to a temperature sufficient for auto ignition like a diesel, the Hundusted Type EL relies on a heated hot bulb chamber. Fuel is injected into this chamber, where it ignites due to the retained heat. This design allowed the engine to run on a wide variety of low-grade fuels, such as crude oil, kerosene, or even whale oil, which made it popular in fishing boats and small coastal vessels. Hundusted's Type EL was typically a slow-speed, single or multi-cylinder engine, noted for its distinctive exhaust sound and heavy flywheel. These engines could run for decades with proper care, becoming a trusted workhorse in Scandinavian fisheries and beyond. Today, surviving examples are prized by collectors and maritime museums as living reminders of industrial ingenuity. The Deutz MAH 716 is a classic single-cylinder diesel engine produced by the German manufacturer KHD Deutz, renowned for its robust and reliable stationary engines. Built during the mid-20th century, the MAH series became widely used in agriculture, industry, and power generation due to its simple construction and remarkable durability. The MAH 716 is a slow-running, air-cooled engine, typically operating at low revolutions per minute, RPM, which contributed to its long service life and fuel efficiency. It employs a direct injection system, ensuring reliable starting and efficient combustion even under heavy workloads. The engine's displacement and power output were suitable for driving threshing machines, small generators, water pumps, and other agricultural or industrial equipment, particularly in rural areas where electricity or modern machinery was limited. One of the most notable features of the MAH 716 is its rugged design, with large flywheels providing smooth operation and the ability to handle varying loads. Its simplicity made maintenance straightforward, requiring only basic tools and mechanical knowledge. These engines earned a reputation for being nearly indestructible, often running for decades with minimal repairs. Today, surviving Deutz MAH 716 engines are prized by collectors and enthusiasts of vintage machinery. They represent an important era of German engineering, where reliability and practicality were prioritized, and they remain a symbol of industrial progress in the early diesel age. Case 22-40 was a two-plow tractor produced by J.I. Case during the early 1910s and 1920s, designed for reliable performance in heavy farm work. Its name 22-40 represented the rated horsepower, about 22 horsepower on the drawbar and 40 horsepower on the belt. This made it one of the stronger tractors in its class, capable of pulling multiple plows and powering threshing machines or sawmills through its belt pulley. The engine at the heart of the Case 22-40 was a four-cylinder, vertical, water-cooled gasoline engine. It had a bore and stroke combination that provided robust torque at relatively low speeds, which was essential for heavy field work. The motor typically operated at around 900 RPM and used magneto ignition, ensuring dependable starts and consistent operation. Its cooling system employed a large radiator and thermosiphon circulation to handle long working hours under load. Farmers valued the 22-40 for its power, fuel efficiency for the era, and its ability to replace teams of horses. The machine represented the transition from steam traction engines to modern internal combustion tractors, making it a key step in agricultural mechanization. Today, surviving Case 22-40 engines are prized by collectors and restorers for their durability and historical importance. The Hine No. 3 Type 2 TR36 horsepower hot bulb glowhead engine is a classic example of early 20th century engineering, representing a transitional stage between steam power and modern internal combustion technology. Hot bulb engines, also known as glowhead engines, were widely used in agriculture, marine vessels, and small industries due to their robust design and ability to run on low-grade fuels, such as kerosene or crude oil. The Hine No. 3 Type 2 TR stands out with its 36 horsepower output, a considerable figure for its time, making it suitable for powering medium-sized equipment. The hot bulb principle relied on preheating a metal chamber before ignition could occur, which meant starting the engine required careful preparation and skill. Once running, however, it delivered reliable power with steady operation and impressive fuel tolerance. Today, engines like the Hine No. 3 are highly valued by collectors and enthusiasts who restore and operate them at vintage machinery shows. These engines are admired not only for their historical significance, but also for their distinctive sound and slow, rhythmic operation, which contrasts sharply with the high-speed diesel engines that replaced them. Although sourcing parts, such as injectors and valves, can be difficult due to age and rust damage, dedicated restorers continue to keep these machines alive. The Hine No. 3 is more than just an engine. It is a reminder of an era when durability, simplicity, and ingenuity shaped the foundations of mechanical progress. The 8-horsepower St. Mary's HVID engine is a classic early 20th century stationary engine built by the St. Mary's Machine Company of St. Mary's, Ohio. Based on the HVID fuel injection system, patented by Rasmus HVID in 1915, this engine represents one of the earliest practical applications of compression ignition technology in American industry. Rated at 8 horsepower, it was commonly used for farm power, small industry, and pumping operations. Its distinctive hit-and-miss style sound and rugged open crank design made it both reliable and simple to maintain. The HVID system injected fuel without a high-pressure pump, relying instead on air movement within the cylinder, a revolutionary step toward modern diesel engines. Today, surviving examples of the St. Mary's HVID are prized by collectors for their mechanical significance and historical value. The Hansat 6 HP hot bulb engine is a fine example of mid-20th century Swedish engineering, produced in 1942 by Vanern's Motorverkstad in Vänersborg. Hot bulb engines, also known as semi-diesels or Glühkopf engines in German, were widely used for their reliability and ability to run on a variety of fuels. This particular model, rated at 6 horsepower, was designed to operate efficiently on crude oil, but it could also use diesel and many vegetable oils, making it highly versatile in agricultural and maritime applications. With an operating speed of 650 revolutions per minute, the engine balanced durability with steady performance. Engines like the Hansat were especially valued in rural areas and on small vessels, where access to refined fuels could be limited. Their rugged construction and fuel flexibility meant they could continue running under demanding conditions, often for decades. The Hansat reflects the ingenuity of its era, embodying both practicality and mechanical craftsmanship. Recorded in operation on August 6, 2013 in Hillerød, Denmark, this engine continues to demonstrate the enduring legacy of hot bulb technology. Today it stands not only as a functional machine, but also as a piece of industrial heritage, preserving the spirit of early Swedish motor design. The Little Skagen Type 7 to 8 HP is a classic Danish stationary engine produced in the 1950s by C.H.R. Christensen's Maskin Fabrik in Skagen, Denmark. Compact yet powerful for its time, this engine delivered between 7 and 8 horsepower, making it suitable for a range of agricultural and industrial applications. With a weight of around 500 kilograms, it was a sturdy and reliable piece of machinery designed to run on crude oil, diesel, and even various vegetable oils, reflecting the practicality and adaptability of mid-20th century engineering. This particular example has been fully renovated by Kevin Spangsdorf Sorensen, who carefully restored it to perfect working order. During the renovation process, a new cylinder was fitted, ensuring both durability and performance. The restoration not only preserved the mechanical integrity of the engine, but also highlighted its historical value as part of Denmark's industrial heritage. In 2015, the little Skagen was showcased at engine rallies, where enthusiasts could witness its smooth operation and hear the distinctive sound of a vintage crude oil engine in action. Today it stands as both a functional machine and a collector's piece, admired for its craftsmanship, resilience, and the important role such engines played in powering rural communities in the post-war era. The Deutz MA 514 is a classic stationary diesel engine produced by KHD Deutz, a German manufacturer well known for its durable and efficient power units. Introduced in the mid-20th century, the MA 514 belongs to the MA series, which was designed for continuous operation in demanding industrial and agricultural environments. It is a single-cylinder, four-stroke, air-cooled diesel engine, recognized for its robust construction and reliable performance. With a displacement of around 5 liters, the MA 514 was capable of delivering steady power outputs in the range of 25 to 40 horsepower, depending on configuration and application. Its design emphasized low-speed operation, making it ideal for tasks requiring long-running hours with minimal maintenance. Common uses included driving generators, pumps, threshers, mills, and other agricultural or factory equipment in rural and industrial settings. A key feature of the MA 514 was Deutz's signature air cooling system, which eliminated the need for radiators or water cooling, reducing complexity and risk of overheating. This made the engine especially well suited to remote or harsh environments where maintenance resources were limited. Today, the Deutz MA 514 is appreciated by collectors and vintage machinery enthusiasts as an enduring symbol of practical engineering and mechanical resilience. Segura Truck Parts CA offers high-quality solutions for heavy-duty vehicles, and one of its standout products is the Mack Engine Start E7 semi-electronic with 350/388 of a horsepower. This engine is designed to deliver the perfect balance between reliability, power, and efficiency, making it ideal for demanding transport and industrial applications. The Mack E7 is well known for its robust construction and long service life. Its semi-electronic system provides better control of fuel injection and combustion compared to older mechanical versions, resulting in improved performance, lower emissions, and optimized fuel consumption. With horsepower ratings of 350 and 388, it gives operators the versatility to handle both medium and heavy-duty loads with ease. Segura Truck Parts CA ensures that every component and part related to the E7 engine meets strict quality standards. Whether for replacements, maintenance, or complete engine solutions, customers can rely on the company's expertise and commitment to durability. By combining original parts with technical support, Segura Truck Parts helps fleets reduce downtime and increase operational efficiency. For businesses that depend on strength, endurance, and consistent performance, Mack Engine Start E7 from Segura Truck Parts CA remains a trusted choice in the trucking industry. The 1915 Case 10-20 is a rare piece of agricultural history, with only 3 known examples surviving today. After more than a century, this tractor has been carefully rebuilt to working condition, preserving both its mechanical integrity and its legacy. Starting it by hand is no small feat. Every turn of the crank carries the weight of 101 years of engineering and farming heritage. The 10-20 represents a time when horsepower was just beginning to shift from animals to machines, and hearing its engine roar back to life is like stepping back into the early days of modern agriculture. The Lister JP4 is a classic British narrowboat engine, admired for its reliability, craftsmanship, and distinctive character. Originally built by R.A. Lister and Company in the mid-20th century, the JP series engines were designed for industrial, marine, and agricultural use. The JP4, a 4-cylinder, slow-revving diesel, quickly became a favorite among boaters due to its smooth operation and long service life. Producing around 33 horsepower at 200 revolutions per minute, the JP4 is well suited for canal cruising, where steady torque and fuel efficiency are more important than high speed. Its design emphasizes durability. Cast iron components, solid engineering, and straightforward mechanical systems make it relatively easy to maintain and repair. Many units built decades ago are still running today, a testament to their quality. One of the hallmarks of the Lister JP4 is its distinctive sound. The rhythmic chug of its exhaust, coupled with a deep mechanical note, is instantly recognizable on the waterways and loved by enthusiasts. Though heavier and larger than modern engines, it brings a sense of heritage and authenticity to traditional narrowboats. For owners who value history, engineering, and character, the Lister JP4 remains a cherished choice. The Anderson oil engine is a notable example of an early 2-stroke diesel engine that contributed to the development of efficient power generation and marine propulsion in the early 20th century. Designed and manufactured by Anderson, this engine was developed at a time when 2-stroke cycle technology was gaining popularity for its compactness and power output relative to size. Unlike the conventional 4-stroke engines, the Anderson 2-stroke diesel completed its power cycle in just 2 piston strokes, 1 revolution of the crankshaft, which allowed it to deliver a power stroke for every revolution.
Another video of it start.
The Anderson engine used a diesel compression ignition principle, where fuel was injected into highly compressed hot air inside the cylinder, eliminating the need for spark plugs. Its 2-stroke design incorporated scavenging ports or valves to manage intake and exhaust, ensuring efficient cylinder clearing and fresh charge entry. This system allowed smoother operation, better fuel economy, and reduced weight compared to equivalent four-stroke units. These engines found applications in marine vessels, small power stations, and industrial machinery, where reliability and simplicity were critical. The Anderson two-stroke diesel was praised for its ruggedness and ability to operate on heavier grades of fuel oil, which were cheaper and more readily available than lighter fuels. Historically, the Anderson oil engine played a role in the broader adoption of diesel power, particularly in shipping, where efficiency over long voyages was paramount. Its design represents an important step in the evolution of compact, reliable diesel engines that paved the way for modern marine and stationary power plants. The 600 HP snow gas compressor is a large-scale, heavy-duty industrial machine designed to handle demanding gas compression tasks in industries such as natural gas, petroleum refining, and chemical processing. Built with robust engineering and precision craftsmanship, it represents an era when mechanical reliability and sheer horsepower were essential to driving industrial progress. With a rating of 600 horsepower, this compressor was capable of handling high volumes of gas at significant pressures, making it indispensable in pipeline systems and processing plants. The snow gas compressor was designed to operate continuously under tough conditions. Its massive frame, heavy cast iron components, and precision machined parts gave it remarkable durability and a long service life. The machine typically featured multiple cylinders to compress gas in successive stages, improving efficiency and ensuring stable pressure output. Its size and power meant it required specialized foundations, cooling systems, and lubrication to function properly. Beyond its technical capabilities, the 600 HP snow gas compressor symbolizes a period of industrial growth in the late 19th and early 20th centuries, when advancements in gas compression technology made it possible to expand energy infrastructure across vast regions. These compressors were often installed at key points along pipelines, ensuring that natural gas could be delivered reliably over long distances to fuel homes, businesses, and industry. Today, surviving examples of the snow gas compressor are admired as feats of engineering history. Preserved in museums or displayed at industrial heritage sites, they serve as a reminder of the ingenuity and mechanical power that helped build modern energy networks. The 20-horsepower Fairbanks Morse N special electric lighting engine was a heavy-duty stationary engine designed in the early 20th century to provide reliable power for electric lighting and other industrial uses. Built by Fairbanks Morse N Company, a well-known manufacturer of engines, scales, and industrial equipment, the N-series engines were renowned for their rugged construction, long service life, and adaptability in rural and urban settings. The special electric lighting engine variant was optimized to run smoothly and steadily at a consistent speed, a crucial requirement for powering early electrical generators and lighting systems. Rated at 20 horsepower, it was large enough to supply electricity for factories, businesses, farms, or even small communities before widespread electrification. These engines typically ran on producer gas, natural gas, or gasoline, and were water-cooled with large flywheels that ensured stable operation. With a simple but durable design, they were easy to maintain and could operate for long periods with minimal supervision. Today, the 20-horsepower Fairbanks Morse N is valued by collectors and enthusiasts of antique engines. Many restored examples can still be seen at historical fairs and engine shows, where they continue to demonstrate the ingenuity that powered the early electrical age. The Ruston Hornsby 5H engine is a classic example of early 20th century British engineering built by Ruston and Hornsby Limited of Lincoln, England. Known for their reliability and robust construction, these stationary engines were widely used in agriculture, industry, and power generation during the first half of the 1900s. The 5H designation refers to a horizontal single-cylinder engine producing around 5 horsepower, making it suitable for tasks such as driving threshing machines, water pumps, saw benches, and other farm or workshop equipment. Constructed with a heavy cast iron frame and large flywheels, the 5H engine was designed to run at low speeds, typically around 450 revolutions per minute, ensuring durability and steady torque. Fuel options often included paraffin, kerosene, or petrol, with a hot bulb or spark ignition system depending on the model and era. The engine's simplicity made it easy to operate and maintain, even in remote rural areas. Today, surviving Ruston Hornsby 5H engines are prized by vintage machinery enthusiasts and collectors. Restored examples are frequently displayed at agricultural shows and steam rallies, where they serve as working reminders of Britain's engineering heritage and the crucial role stationary engines once played in powering everyday life. The Cooper Tandem gas compressor engine is a historically significant piece of industrial machinery widely used in the early to mid-20th century for natural gas transmission and processing. Manufactured by Cooper Bessemer, a company recognized for its heavy-duty engines and compressors, the tandem gas compressor engine combined reliability with efficiency, making it a workhorse in the oil and gas industry. The tandem designation refers to its configuration, where 2 power cylinders were aligned in series on a common crankshaft. This arrangement allowed the engine to deliver greater horsepower and smoother operation, while reducing vibration compared to single-cylinder designs. Connected directly to a reciprocating compressor, the engine compressed natural gas to high pressures for pipeline transport or storage. Typically fueled by natural gas, the Cooper Tandem offered an economical advantage, as it could run on the very product it helped move. With its robust cast iron construction and heavy flywheels, the engine was built for continuous operation under demanding conditions. Maintenance crews appreciated its durability and straightforward design, which allowed for long service lives with proper care. These engines played a critical role during the expansion of natural gas infrastructure in North America, powering compressor stations that enabled long-distance gas transmission. Though largely replaced today by modern turbine-driven compressors and electric motors, many Cooper tandem gas compressor engines remain preserved in museums and by enthusiasts. They stand as a testament to early engineering innovation that supported the growth of energy industries and modern infrastructure. The Atlas Imperial engine is a remarkable piece of maritime engineering history, known for its sheer size, strength, and enduring legacy. Making its official debut at the 24th Annual Mystic Seaport Marine Engine Show in 2014, this massive engine quickly captured the admiration of enthusiasts and historians alike. Weighing an impressive 18,000 pounds and producing 135 horsepower, the Atlas Imperial is not just a mechanical powerhouse but also a testament to early 20th century craftsmanship. Atlas Imperial engines were originally built for workboats, fishing vessels, and tugboats, where their reliability and efficiency made them invaluable. Their robust design allowed them to endure the demanding conditions of marine service, and many continued to operate for decades after their installation. The engine size alone speaks to the industrial confidence of its era, embodying the mechanical ingenuity required to power working ships across America's waterways. At Mystic Seaport, the Atlas Imperial stands as both a functional machine and a historical artifact. Its presence bridges the gap between past and present, allowing visitors to experience firsthand the technology that kept maritime commerce moving. For many, the rhythmic sound of the engine in motion evokes nostalgia for a bygone age of marine engineering. Today, the Atlas Imperial engine represents more than horsepower and tonnage. It symbolizes endurance, tradition, and the spirit of maritime innovation. Its preservation and continued exhibition ensure that future generations can appreciate the role these engines played in shaping the working waterfronts of the 20th century. The motor Pouyad SSCM 17700 Sergers France refers not to a single widely documented engine model, but rather locates it in the context of the Pouyad SSCM heritage in surgeries, postal code 17700. Below is a summary based on what is known of Pouyad SSCM and their place in French industrial history. The company Pouyad was founded by Abel Pouyad and Sergeris, originally as a small workshop building gasoline engines for local agricultural use around 1909-1910. In 1918, Pouyad merged with partners to form the Société Sergerienne des Constructions Mécaniques, SSCM, which then expanded into manufacturing heavier engines, semi-diesel and later full diesel engines, often for marine, generator, or industrial use. The site at Sergeris, postal code 17700, was a central location in Pouyad's operations. The company built large engine workshops there, benefiting from a railroad siding and access to materials. For many decades, the Sergeris factory was Pouyad/SSCM's industrial heart, producing engines and serving as a maintenance hub. By the latter part of the 20th century, however, Pouyad's original production role had declined. After being absorbed by SACM and ultimately by Wärtsilä, the surgery site shifted from manufacturing toward maintenance, repair, and servicing of Pouyad/Wärtsilä engines, rather than producing new ones. Thus, an engine labeled Motor Pouyad SSCM 17700 Sergers likely refers to a Pouyad SSCM diesel or marine engine originally built or serviced in the Cergeras facility. While specific technical data, power, displacement, etc., for a 17,700 model isn't readily found in open sources, it fits into the broader line of Pouyad's durable, long-lived engines used in marine, generator, and industrial settings. The Klimov VK-1 was a Soviet axial-flow turbojet engine derived from the British Rolls-Royce Merlin. It powered the MiG-15 fighter, one of the most significant jets of the Korean War. Compact, reliable, and powerful, the VK-1 enabled high speeds, strong climb rates, and superior combat performance against early Western aircraft. The Jezera Mountains Technical Museum chainsaw engine is a fascinating highlight for visitors interested in engineering history and forest traditions. Located in the picturesque Jezera Mountains, the museum preserves and showcases tools, machines, and inventions that shaped local industry and daily life. Among its most unique exhibits is the chainsaw engine, a symbol of both innovation and hard physical work in forestry. This display not only illustrates the evolution of mechanical design, but also reflects the strong connection between the region's people and their natural environment, making it an inspiring stop for history and technology enthusiasts alike. The Deutz MIH 336 diesel engine is a robust, medium-speed power unit developed by KHD Deutz, a German manufacturer known for durable and efficient diesel technology. This engine belongs to the company's marine and industrial engine line, designed for applications requiring long operating hours, consistent performance, and fuel economy. The MIH 336 is a 4-stroke, turbocharged, water-cooled engine with inline or V-type cylinder configurations, depending on the application. Its displacement and power output vary by model, but it is generally built to deliver between the medium and high horsepower range, making it suitable for ships, locomotives, and heavy-duty industrial machinery. The engine is engineered for continuous duty, offering reliability even under harsh conditions such as marine propulsion or generator operation in remote areas. One of the defining features of the MIH 336 is its sturdy construction and modular design, which allows for easier servicing and overhauls. The engine is equipped with direct fuel injection, ensuring efficient combustion, good fuel economy, and compliance with emission standards of its era. It also incorporates forced lubrication and efficient cooling systems to extend service life. Deutz engines, including the MIH 336, gained a reputation worldwide for being low maintenance, fuel efficient, and long-lasting. Even decades after production, many units remain in operation, supported by spare parts availability and refurbishment programs. For operators in marine transport, stationary power plants, or railways, the Deutz MIH 336 continues to represent German engineering reliability.
Ansonsten, wenn man mit weniger Drehzahl fahren will, muss ein anderer Pumpenstößel verbaut werden, damit er später einspritzt, und eine andere Reglerfeder rein, damit er dann im unteren Bereich sauberer regeln kann.
The Deutz E12 gas engine, introduced in 1904, represents an important step in the early development of internal combustion technology. Built by Gasmotorenfabrik Deutz AG in Cologne, Germany, one of the world's oldest engine manufacturers, the E12 was designed during a period when stationary gas engines were rapidly replacing steam engines for industrial power generation. The E12 was a single-cylinder, horizontal, water-cooled gas engine known for its durability and reliability. Running primarily on town gas or producer gas, it was often employed in factories, workshops, and agricultural settings to power machinery, such as pumps, mills, and saws. Its design emphasized efficiency and ease of maintenance, featuring robust cast iron construction, simple valve gear, and low operating speeds, which reduced wear on moving parts. One of the most notable aspects of the E12 was its role in making internal combustion engines more accessible to small and medium-sized enterprises. Unlike steam plants, which required constant supervision and large infrastructure, the Deutz gas engine was relatively compact, safe, and easy to operate. Its reliability earned it a reputation as a workhorse of early industrial power. The E12 also reflects the broader engineering philosophy of Deutz, a company co-founded by Nicholas Otto, the inventor of the four-stroke cycle. This heritage is evident in the engine's solid performance and innovative use of gas as a fuel source, at a time when petroleum was not yet widespread. Today, surviving examples of the Deutz E12 are prized by collectors and museums as milestones in the history of mechanical engineering. The Campbell stationary hot tube engine is a classic example of early internal combustion technology that bridged the gap between steam power and the modern gasoline engine. Built by Campbell, a British manufacturer known for robust stationary machinery, this engine was designed to provide reliable power for agricultural, industrial, and workshop applications during the late 19th and early 20th centuries. Unlike steam engines, which required boilers, water, and constant supervision, the hot tube engine used a simpler method of ignition. A metal tube, heated externally by a small burner, glowed red hot. As the compressed air-fuel mixture entered the cylinder, it ignited when it touched the hot tube, driving the piston. This design eliminated the need for complex valve gear or electrical ignition systems, making the engine relatively easy to maintain in rural areas where technical support was limited. The Campbell hot tube engine was typically a single-cylinder, horizontal stationary engine, mounted on a heavy cast iron frame to reduce vibration. Speeds were modest, but torque was high, making it suitable for tasks such as pumping water, driving threshing machines, sawmills, and other belt-driven equipment. Its reliability and durability earned it a reputation as a dependable workhorse. Although hot tube ignition was eventually replaced by more efficient spark ignition systems, engines like the Campbell stationary hot tube model played an important role in mechanizing agriculture and small-scale industry. Today, surviving examples are prized by collectors and engine enthusiasts, who preserve and demonstrate them at vintage machinery rallies, keeping alive the heritage of this ingenious and practical technology. The Type RTGB3 marked an important milestone in the history of Bergen diesel, being the company's first four-stroke engine and a decisive step in modern diesel engine development. Introduced as a compact yet powerful unit, the RTGB3 reflected Bergen's ambition to move beyond the traditional two-stroke designs that had dominated earlier decades. This three-cylinder engine was capable of delivering 280 horsepower at 600 revolutions per minute, equivalent to 205 kilowatts, a considerable figure for its size and era. Each cylinder had an impressive displacement of 17.66 liters, giving a total of about 53 liters, which highlights its robust capacity for sustained power generation. With a bore of 250 millimeters and a stroke length of 350 millimeters, the RTGB3 combined a long stroke configuration with solid torque characteristics, making it well suited for marine and stationary applications, where reliability was paramount. The engine weighed approximately 500 kilograms, reflecting the heavy-duty materials and construction required for durability under continuous operation. Despite its relatively modest cylinder count, the RTGB3 proved to be a reliable workhorse, embodying the qualities of sturdiness and efficiency that later became synonymous with Bergen diesel products. Beyond its technical specifications, the RTGB3 represented a turning point. It demonstrated that Bergen diesel could successfully design and produce four-stroke engines, laying the foundation for future generations of high-performance medium-speed diesels. Its introduction established Bergen as a serious competitor in the international diesel engine market, where its later models would go on to power ships, power plants, and industrial facilities worldwide. The RTGB3 was a milestone in the history of Bergen diesel, marking the company's entry into the four-stroke engine market. Introduced in the early post-war period, this engine type represented a significant technological leap forward from the traditional two-stroke designs that had dominated Bergen's production since its founding in 1946. While the company had established a solid reputation with rugged, reliable two-stroke diesels for fishing vessels and coastal shipping, the RTGB3 was its first step toward more fuel-efficient and versatile propulsion systems. As a four-stroke engine, the RTGB3 brought several advantages. It offered improved fuel economy, cleaner combustion, and lower maintenance intervals compared to two-stroke models. This made it attractive to ship owners seeking to cut operational costs and comply with evolving requirements for reliability and durability at sea. The designation RTGB followed Bergen's naming conventions: R for engine series, T for turbocharging, G for geared configuration, and B for Bergen. The three denoted the first generation of this new four-stroke development. Technically, the RTGB3 featured turbocharging to boost efficiency and power output, which was forward-looking at the time. It was designed in medium-speed format, allowing it to serve both as a main propulsion engine for smaller merchant vessels and fishing trawlers, and as an auxiliary or generator engine in larger ships. Its modular cylinder design reflected Bergen's philosophy of easy maintenance and adaptability, a principle the company carried forward in later designs. The introduction of the RTGB3 paved the way for Bergen Diesel's future as a leading supplier of medium-speed four-stroke engines. Later models, such as the BR and K series, would refine these concepts further, but the RTGB3 holds the distinction of being the foundation. It was not just Bergen's first four-stroke, it was the starting point for decades of innovation that eventually established Bergen as a respected global brand in marine and power generation engines.